All right, so let's leave the moons of Jupiter behind, and obviously the Galilean moons are the most interesting ones, especially Europa and Io, and to some extent Ganymede is interesting too. Um, Callisto is Poor Callisto is just this this heavily cratered object. Though um, uh, perhaps the most heavily cratered object, at least up to now, the most heavily cratered object we've ever seen in the solar system. So it has not changed its surface at all since it was created 4.5 billion years ago. All right, so let's move on to Saturn, the next planet out. Of course, it's not as big, certainly as Jupiter. I mean, Jupiter is much larger than Saturn. Um, yeah, I guess I should say something about. Let me talk a little bit about Jupiter before I move on to Saturn. Jupiter, sometimes you hear people talk about that Jupiter is a failed star. It's nowhere near being a star, even though it's the largest planet in the solar system by far. Um, it would have to be about 80 times the mass that it already has. Right? It already has an enormous amount of mass, but you'd have to add 80 times that mass to it for it to be even the smallest of stars. So yeah, Jupiter is far from ever of having become a star. All right. So anyhow, so we get to Saturn. One of the first things you notice is the surface of it. Well, of course, you notice the rings. Of course, that's pretty much what people think of when they think of Saturn. We'll get more into the rings in particular. Um, or more, we'll study the rings a little bit more in detail. They are mostly particles of ice. It's really thin. The disk itself is very thin. It turns out. But if we look at the surface of, or sorry, the upper atmosphere. Remember, it's a gas giant. It doesn't have a surface. Um, the upper atmosphere, it doesn't seem to have as many features as Jupiter. With the zones and the belts. It actually they are there. It's just really hard to see them because of the composition. It's a slightly different composition. I mean, it's made of the same stuff, mostly hydrogen and helium, um, but like the amount of ammonia and methane um, is different than the amount of methane and ammonia that's in Jupiter's atmosphere. All right, so Saturn is about 10 times the diameter of the Earth, and so you could fit 10 Earths across it, and it's about 95 times the mass of Earth. But notice the density, right? So remember, Jupiter was a little bit more dense than liquid water. Remember, liquid water has a density of 1 gram per cubic centimeter. So when you do the density, when you measure the density of Saturn, the density is even less than that of liquid water. All right, so um, uh, that it turns out to be the least dense planet in the entire solar system. So there's one of the things is quite different about it. Um, so we think that the density makes it it has more hydrogen than it has and of course hydrogen compounds than it has any heavier material. Remember, Jupiter we think might even have a rocky core. Um, so it says here Saturn, it looks different than Jupiter. The temperature is low enough for ammonia gas to freeze into the clouds, and so the ammonia gas, the frozen gas, will it prevents us from seeing deep inside of Saturn's atmosphere. But if you use that's in the visible part of the spectrum. If you use like infrared and things like that, you can actually start to see the zones and the bands. All right, so this is, here's a cutaway of, and again, so let me just start by saying Saturn had um, a spacecraft. It was called the Cassini spacecraft that orbited Saturn for many, many years. Um, I think Cassini orbited for close to 20 years. I think I might have said Galileo. Galileo, which was a spacecraft that orbited Jupiter. Um, I can't remember how long it orbited. I could look it up, but it's one of them lasted for like 10 to 15 years, and the other one lasted about 20 years. And I think it was actually I might have been wrong in one of my other slides when I said Galileo lasted for 20 years. I think it was actually the Cassini spacecraft. Um, all right. Anyhow, so the Cassini spacecraft gave us most of our information about Saturn, and once again, the Voyager spacecraft passed by in the 1980s. They passed by Saturn because of that alignment. Remember that Voyager 1 and 2 were launched in 1977. When Voyager 1 got here, there was something going around Saturn that was so interesting that we actually so for the Voyager. Remember, the Voyager spacecraft only passed by, right? They never went into orbit around. We didn't really know how to do that very well back then. When the Voyager 1 spacecraft passed by, it actually ends up traveling so if this is the plane of the solar system, right through the middle of Saturn, going all the way back towards the sun. When the Voyager spacecraft got here, it traveled like this. So it traveled perpendicular in a direction perpendicular. All right, and we're going to find out why shortly. There's a really good reason, because of Saturn's largest moon, as a matter of fact, that we decided to deflect the Voyager spacecraft. NASA scientists decided to deflect the Voyager spacecraft to get a better look at Titan. All right. Anyhow, we'll get to that later. Just like Jupiter, Saturn gives off more energy than it receives from the sun. However, we don't think it's because Saturn is so much smaller than Jupiter. We don't think it's because of the heat of formation. Remember, Jupiter's massive compared to Saturn, and so it's still radiating out its the original heat of formation. Rather, the source of Saturn's heat was actually a mystery for a long, long time, but now we think what happens is the helium droplets, all right, in the atmosphere of Saturn, there's helium droplets, and they will condense. So they go from being a gas to turning into a liquid, and when they do that, they release some heat. All right, so that's actually very well known. That's called the latent heat. We don't understand that quite well. When matter makes what's called a phase transition, when it goes from being a gas to a solid or a solid to a gas, there's this latent heat. All right. Anyhow, let's. All right. So this is taken with different. Actually, like this is actually part of the visible. So there are some times that you can actually see some cloud formations, some storms on Saturn. But over here on the left hand side, this is showing the zones. Remember, the zones are the whiter areas, and the bands or the belts. Some people call them belts. So the darker regions. But that's looking in the infrared region. So you can really see the zones in the belts there. This was a picture taken by the Cassini spacecraft. There was a brief disturbance. Yeah, I forget how long this lasted. That could be seen. There are even sometimes where you see little hurricanes going on. So this was some kind of storm pattern on the upper clouds of Saturn. Remember, Saturn's spinning around just like Jupiter, just like all the planets, of course. But because it's a gas giant, it doesn't rotate as a solid, and so there's an extreme Coriolis effect. The same kind of thing that happens with the Earth's atmosphere, right? There's a Coriolis effect that occurs because the Earth is spinning. Let's see. So we see storms. We see. These are not very permanent features on. We don't see these over the course of centuries the way we see the Great Red Spot on Jupiter, right? These things come and go relatively with just over short amounts of time, maybe a month or two at the longest. So the rings are really wide. They extend many kilometers out from Saturn. These are mostly ice particles. There's actually other stuff in here called shepherd moons. We'll get to those later. This is actually what Cassini was an Italian astronomer that had a telescope. So he lived after Galileo. I forget how long. Maybe like I don't know exactly his dates, but he lived maybe within 100 years or so after Galileo. But he built a telescope that was powerful enough to actually see this gap right here. And so this gap has been called ever since the Cassini gap, and it was actually what the spacecraft was named, that orbited Saturn for like I said, about almost 2 decades. All right, so Cassini, that's the Cassini gap. There's actually other gaps. There's a where you can't really see it. I think it's right here. There's a thing called the ankle gap. Anyhow. So the thickness of the ring. So like if you were to look at it like a record or something like that, it's really really thin. Like it doesn't, and it isn't more than just a few hundred meters. Like remember, 100 meters is like the size of a football field. So a couple of football fields thick. But it goes out many, many thousands of kilometers out into space. And the reason that we can see this very easily with just a small pair of binoculars, even Galileo, he didn't really know what he was looking at, but Galileo actually saw the rings with his and wrote it down. Right, he recorded this. He saw something. He didn't know exactly what it was, but he wrote down that there were these something coming off the planet. And remember, his telescope wasn't very powerful, but he was able to see them even with a small pair of binoculars. Nowadays, I mean, binoculars are much more powerful than Galileo's primitive telescope, 400 years ago. But even with a pair of binoculars,